So as I've been building out a game with C# in Unity, there's a lot of object-oriented programming that you have to deal with. And when you deal with object-oriented programming, there's a lot of polymorphism in interfaces. So I wanted to talk a little bit about those. And if you're kind of new to programming, this will kind of help clear things up. So when it comes to object-oriented programming, typically you have things like classes. I'll make a square here for a class. And again, when I'm speaking, you may not even know Unity or you may not even know C#. It doesn't matter. You need to be able to think at a higher level of abstraction and apply that to whatever language that you may be using. Because I guarantee you, whatever language you're using right now probably has this concept of objects, and interfaces, and types, okay? So in object-oriented programming, typically you have like a class. And when you have that class, it has a bunch of different methods on it. So you might have like a, I don't know, get health method. You might have like a damage method, and I'm going to scope this for game programming because that's kind of like what the example is right now. But you could do this for any type of programming. And I'm going to name this like the player class, right? Okay. So this is pretty good. You have like a little player class. It may have like a, a health variable in it. So I'll say like health, maybe that's an int, and it has these methods on it. Then we might also have something like a, I don't know, a breakable object class. So I'll just call it breakable class, right? So for example, in this game, there's a cube here. And if you go up and you smack it, maybe after 3 hits, it destroys itself. Okay, so we have a breakable class. Again, it has health on it, and it probably has a method that you can use to damage it. Maybe it has a get health function. In fact, I'm just going to get rid of get health to keep this as simple as possible. So when you're building out these classes, you may notice that there's a overlap with the variables that are on it and methods that can be used to change those variables. Now, one approach that you can do to kind of share that information is by using like an abstract class or a parent class. I'm not going to talk about that, but that is another form of like polymorphism. You can have an abstract class called a damageable entity or damageable thing, and both of those can extend that to get some baked in logic. But we're not going to be talking about abstract classes and getting inheritance that way. We're going to be talking about an interface where when you have some shared functionality, sometimes you'll have another class down here. So let's say we have like a weapon. Okay, so I'm going to say a weapon class. And this has some update logic, like maybe it has like an attack method. And inside that attack method, it has to go and loop through and get all of the objects that are in front of, a vector. Okay, if you're thinking about 3D, typically there's like a direction that the player is facing, and you can get, using ArrayCast, all of the objects that are like directly in front of the player. So when a user like presses the attack button on their keyboard, that's probably going to invoke your attack method, and then your attack method needs to find all classes in front of it. But the issue is that when you have, let's say, 10 or 20 or even 100 different types of classes that are all damageable, this method, you do have to have some type of way to check to see, hey, do you have the damage method? Now, if you're using JavaScript, it would be very easy. You could just say like if object.damage, then you can just go ahead and call it, right? You could just do something like this and then object.damage and then invoke it. And of course, if you're kind of well-versed in JavaScript, you could just do this, which would optionally call the method if it exists. So this is super easy in JavaScript, but with statically typed languages like Java and C#, you can't really just do that. Now, one thing we like to do to show dependencies is you could draw an arrow. So you could say the weapon class is kind of dependent on the player class and the breakable class, so it knows the functionality of this. And that can be kind of problematic from a code management standpoint, because now the weapon class has to have knowledge of how the player class is implemented and how the breakable class is implemented. And it may, when you compile your code, it may bring in a bunch of extra stuff. It just may make your code a little bit less flexible. So instead of the weapon class depending on these concrete implementations, what you could do is you can make an interface. So I'm going to say damageable interface, and I'll just go ahead and put it right in between these two classes. So now instead, the player class is actually going to depend on this interface. The breakable class is going to depend or extend the damageable interface. And interfaces don't really have a way to define variables, so I'm going to delete that one. So now the weapon class really only depends on some type of damageable interface to figure out, can it attack the object or not? And both of these now can extend that damageable interface, which guarantees that they're going to have some type of damage method implemented. And sorry, I keep saying extends. This is implements. Implements. I don't know why I keep saying extend, so I apologize for that. I'm editing the video and adding that part in because I think it's confusing. Now, the one issue with the interface is that a damage method, like let's say you have 100 of these different classes, you end up having to re-implement a damage method for every single class. So one approach that you could do is you could probably inject some type of shared logic object. So like when you construct the breakable class, you inject an object that knows how to compute the damage so that your damage method can simply just call that helper function or that helper object. I'm not going to dive into that, but just know that there's design patterns to reuse code and inject it in the constructor or set it dynamically so that when these things are damaged, they can change how they get hurt, right? Sometimes you want the object to flash red. So maybe you could have like a red flash damageable concrete thing that you pass in when you implement the class. Anyway, hopefully this is making sense. Probably not, but let's just go over to the code real quick because I want to show you. So I have a box right here, a cube. And if I were to join the game, all right, so I am spawning as a player. And now if I go up to the box, if I click it, notice that it does hurt it some, right? So if I click it again, it should get removed. So if I look at this object, it has a breakable script on it. So let's look at the code real quick. And again, if you don't know C#, it's fine. You can probably still follow along. But the main point is that you have an object that extends some type of damageable interface, right? If I look at the damageable interface, it requires that whatever class is extending it has an apply damage method and a request take damage method. But notice that the interface doesn't declare any variables and there's no functionality. It's just like a top level contract that says, hey, if this thing is going to be damageable, it must have these two methods. So why is this important? If I look at the melee weapon class, somewhere along here, it's kind of doing that logic where it does a raycast and gets the object directly in front of it. And the key thing I want to talk about here is that I'm getting any component that happens to have an damageable interface attached to it, right? So instead of actually like looking for a player controller here or looking for a breakable box or something, you're just looking for some object using polymorphism that extends or implements the damageable interface. And then once you get it, you know that you have two methods on it. You have a request take damage method, and you also have an apply damage method. So that's how polymorphism and interfaces kind of work. And I've seen that a lot with Unity game dev and object-oriented programming, where you have like this functionality where you have to apply damage or apply health or whatever to various different game objects. Typically, you want to use interfaces to make this a more maintainable type of code base. But let's quickly just look at the breakable thing. So this is actually implementing the damageable interface, which means that it must create an apply damage method, which here's the actual concrete implementation details of this method. It basically just takes in an amount and it decrements the current health from that amount that was passed in. And then it flashes the object red. And then if the object gets under a certain health, I just go ahead and remove it. Okay. And then also the interface requires that I have a request take damage method, because these could be server objects or they could be client objects. And I need to differentiate, hey, do I need to send a message to the server to tell the server object to take damage, or can I just decrement the damage right here in this method, right? Again, why is this so important? Because now I can take that breakable script and I can literally put it on anything in my game. Like I can go over here and say, okay, this is going to be breakable now. Go ahead and say yes. I think it also needs to have like a transform. Let me just go ahead and do that. And now I can join the game, and that tree, I should be able to run up to it and smack it twice, and it should get removed from the game. So let's just try this out. We'll go to the tree, smack it, and it's gone. Okay. So that was my little overview of how inheritance works. Leave a comment if there's something else related to like object-oriented programming or design patterns you think I should cover. I hope this was useful. Have a good day and happy coding.